let's talk a little bit about the rational zero theorem. This is not one of my favorite theorems. I don't like it because it's really narrow and we don't really need it. This is kind of a relic of when we used to have to try to solve these by hand. Even for that, it's not that useful, but it's easy. So just hang with me. We're just going to figure out how to do it. So what the rational zero theorem is let's say you have a polynomial like this that has all integer coefficients. Okay. So if your polynomial isn't dealing with, or it doesn't have integer coefficients, this is already useless. Okay. And what we're going to try to do is find an exhaustive list of all possible rational zeros. Now, remember, rational zeros are something like 2/3 or 7, because 7 could be written as a ratio as well. That's like 7/1. It won't help us find irrational stuff like square root of 7 or complex stuff like 2 + 3i. So won't help us find these, but if, and that's a big if, this thing has rational zeros, it's going to be on this list that we make right here. Okay, so the way that we do this rational zero theorem is we take the constant value and we break it up into all of its factors. So 15 and 1, 5 and 3. Okay, and then we break the leading coefficient up into all of its factors. So that would be 6 and 1, 3 and 2. And then what we basically do is we take every combination of these, and those are going to be our possible fraction solutions here, our fractional roots. So, for example, 15/1 is just 15. 5/1 is 5. 3/1 is 3. 1/1 is 1. So I finished this guy. Now we do 2. 15/2. 5/2. Make sure you can see everything I'm doing over here. 3/2. 1/2. All right, now let's do 3. 15/3 is 5. We already got that. 5/3. 3/3 is 1. We already have that. 1/3. Okay, so this guy's done. 15/6. That's going to be 5/2, which we already have. 5/6. 3/6, that's 1/2, which we already have, and 1/6. And not only are all of these possible, but also their negative counterparts are also possible. So on your homework, it'll say like plus or minus all of these guys. Well, how do we find which rational zeros they have? Well, I would shove it in Desmos, but they're wanting you to like guess and check on all of these. So guess what? I've already done it for you. And drum roll, please. None of these are solutions. There's no rational zeros in this. So this doesn't guarantee that there are going to be rational zeros. What it says is, if you have any rational zeros, it's going to be on this list. Okay. Again, not my favorite theorem, but here we are. All right, so let's take a look at this guy. We're going to do the same thing. This is going to be a much easier problem. So we take this guy and we find all of its factors. This guy's prime, so it's going to be 17 and 1. This leading coefficient is 1. So divide this, we've got 17. We've got 1. and it's plus or minus. So it could be 17, 1, -17, or -1. So only 4 possibilities, unlike this monstrosity over here. So again, if it asks you to find all of the possible rational zeros, it's your last coefficient, all of its factors, divided by all of the factors of your leading coefficient. All right, here you go.